Hi to our beloved viewer. Welcome to our video. My name is Muhammad Salahuddin. My other two group members is Muhammad Amin Mukri and Jesh Nairi Johannes. We are from group 2, and today in this video we'll be presenting on comparing pre-stressed and reinforced concrete for sustainable construction. Construction is one of the largest contributors to carbon emissions worldwide. Since concrete is the most widely used building material, the choice of structural system can make a huge difference in sustainability. In this presentation, we'll cover definitions, material efficiency, durability, construction impacts, carbon footprint, end of life flexibility, and finally the summary comparison. So I would like to give the next presenter to present our slide.
Hello, greetings to viewers, and right now I'm going to present about why sustainability is really important in construction. First of all, my name is Disney Johannes Jawi, and then I'm going to present about sustainability. First of all, construction is a major source of carbon emission and waste, like cement and steel, energy consumption for heating, cooling, and transportation, and people surrounding around us. And generally, concrete is the most used building material worldwide. And choosing the right structural system helps reduce material use, lower environmental impact, and improve building lifespan. Alright, next, I'm going to present about the basic definition of two structural, which is prestressed concrete and reinforced concrete. So the first one is reinforced concrete. Reinforced concrete is a concrete and steel bars to resist tension, and it's really common in low-rise building, like one-story building or two-story building. And the second one is prestressed concrete. Steel tendons tension before or after casting. Concrete kept under compression and used for long span like bridges, slab, and parking decks. So there's a simulation or a demo for prestressed concrete. So let's say this is a steel bar, and they're gonna stretch it, and then they pour the concrete for the casting. Okay, just like that. Alright, so the last one for me is the material efficiency between reinforced concrete and prestressed concrete. So the first one I will explain about reinforced concrete. So reinforced concrete has larger beams or slab required and higher cement and steel consumption. And then the prestressed concrete, it has smaller section, less concrete and steel, so it's saving a lot of material consumption, so it can lower the percentage of carbon footprints. So in conclusion, the sustainability advantage goes to prestressed concrete because it's consume a really low percentage of carbon and low material usage. So that's all from me. Thank you.
Durability and service life. Pre-stressed concrete also has higher durability because the concrete is under compression. Cracks are reduced, lowering corrosion risk and extending service life. This means less maintenance and repair over time. In contrast, reinforced concrete tends to crack earlier, especially under heavy loads, leading to higher maintenance needs, increasing material use over the building lifetime. And the next one, construction impact. Pre-stressed components are usually precast in factories, providing better quality control, reduced site waste, and faster installation. Meanwhile, reinforced concrete is often in situ, which involve more formwork, on-site labor, and higher risk of rework or wastage. So, pre-stressed concrete is more suitable and sustainable in terms of construction waste management. The next one, carbon footprint. Cement manufacturing is a major source of CO2 emission, so minimizing concrete volume helps to reduce the carbon footprint. Since pre-stressed concrete uses less concrete and less steel, its embodied carbon is lower throughout the building life cycle. Although pre-stressed concrete requires special equipment and skilled labor, overall it still contributes to lower carbon output compared to reinforced concrete.
So, for the end of life and flexibility for these two type of concretes, first, the pre-stressed concrete is harder to demolish or modify, making it less adaptable. For the reinforced concrete, it is easier to dismantle and more flexible for renovations. We move on to the next slide. Let's summarize these two items. For the pre-stressed concrete, it uses less material, has higher durability, lower maintenance, less waste, and a smaller carbon footprint. For the reinforced concrete, on the other hand, is more flexible, easier to modify, and better suited for smaller scale projects. So let's conclude this presentation. Pre-stressed concrete clearly offers sustainability advantage such as material efficiency, improved durability, reduced waste, and lower life cycle emissions. For the reinforced concrete, it remains valuable for smaller projects, flexible layouts, and situations where technical simplicity is preferred. In short, both systems have their place, but for sustainable construction at scale, pre-stressed concrete provides significant long-term benefits. That's all from us. Thank you for listening. Thank you for liking this video, and we'll be happy to take any questions down below in the comment section. Bye.